Okay, so this is a recording for use as a walking, talking mock. We're going to be looking at the specimen paper for the Edexcel statistics unit of the applied paper. So this is part A of the applied paper, and we're just going to go through the questions, being smart about what to think. Okay, so question 1. A company manager is investigating the time taken, T minutes, to complete an aptitude test. The human resources manager produced the table below of coded times, X minutes, for a random sample of 30 applicants. Use linear interpolation to estimate the median of the coded times. Okay, so firstly, I'm just noticing that they've mentioned coded so many times. At some point, we should be doing some sort of uncoding. All right, so linear interpolation to find the median. Straight away, since I'm looking at a frequency table, I'm just going to see whether the upper limit and the bottom limit of consecutive intervals, whether they match or not. If they didn't match, I would definitely need to close those gaps. At the moment, this is fine. These ones do match. The very next thing that we want to do is to produce the cumulative frequency. Okay, I just like to add it to the frequency column so all the numbers are close by. Okay, so those are my cumulative frequencies. I ended on 30. I was expecting to end on 30 since the question did say there were 30 applicants. All right. 2 marks here, so quickly let's show linear interpolation. Firstly, where am I looking for the median? So what position am I going to look in? 31 divided by 2. The 15.5 value. All right, which interval is that going to be in? The first interval ends on the 3rd value. The second interval ends on the 18th value. So I must have gone past the 15.5. It's going to be in that second interval. It's going to be in here. All right, let's set up our diagram. Well, that group goes from 5 minutes to 10 minutes. The positions within that group go from the 3rd value to the 18th value. And I'm looking to track down the 15.5, expect it to be closer to 10 than it is to 5. I'm going to use that as a sense check as I produce my final answer. Okay, from here we can make 2 equations. Okay, so from here there's 2 fractions that we're going to set up, and we're going to try and solve for those fractions. Okay, so Q2 minus 5 divided by 10 minus 5 should equal 15.5 minus 3 over 18 minus 3. Okay, simplify and rearrange. Q2 minus 5 over 5 equals 12.5 over 15. Okay, and a couple more steps of rearranging. I'm going to multiply the right hand side by 5, and I'm going to add on 5. So okay, all of that into your calculator. Right, and we get 9.1616 as my median. Okay, moving on. Next we'll ask to estimate the standard deviation of the coded times. So standard deviation, straight away, a few things that we know we need. We're going to need X bar. We're going to need to calculate S of XX. And then finally, we can find the standard deviation. X bar, S of XX, and then finally the standard deviation. Okay, so those values, a lot of them have been given to us already. We had some summary statistics up here. Definitely going to make these calculations just that little bit easier. Let's sub in what we need. So this is 355 divided by 30. Right, that's 71 over 6. I'm going to leave it as the fraction for now, just so that I can maintain accuracy throughout my calculations. The S of XX. The sum of fy squared, given to us in the question. N is 30 once again, and I'm going to put the fraction straight in there. Okay, now this is going to go into my calculator. So I'll get 8845 over 6. Let's just check how the decimals do come out. Okay, got that 1/6 recurring happening again. Okay, so those are the values for x bar s of xx. Standard deviation now, using the answer that I had on my calculator and square rooting, standard deviation comes out to be 7.1297. Okay, so what's next? The company manager is told by a human resource manager that he subtracted 15 from each of the times and then divided by 2 to calculate the coded times. Okay, so they've given us the coding. They haven't given it to us in an equation form, but he subtracted 15 and then divided by 2 to calculate the coded times. Calculate an estimate for the median and the standard deviation of t. Okay, so first thing I'm going to do is I'm going to write down the actual coding. So the original values, t, he subtracted 15 from them and divided by 2, and that's how we came up with those y values. That's the coding that was used. Can I uncode and make t the subject for each of these? All right, so for the mean, or I should actually say for the median is going to be affected by both the subtraction and the division. So let's say this, Q2 for y. So let's go ahead and rearrange that, trying to make Q2 for t. So the median for t, the subject, I'm going to multiply it by 2 and then add on the 15. Okay, so that's how I'm going to uncode this data. How about for the standard deviation? Remembering standard deviation, addition and subtraction do not impact standard deviation. So the standard deviation for y equal to standard deviation for t divided by 2, and the rearrangement here lets me know that the standard deviation for t is going to equal 2 times the standard deviation for y. All right, just plugging in those values now should give us what we're looking for. Remind ourselves of the median. The median was 9.16 recurring, or 55 over 6. So here, the median of t, which is the original times, should just be 2 to maintain as much accuracy as I possibly can. And I got quite a nice answer, 100 over 3, 33.3 recurring. My standard deviation for t going to be 2 multiplied by 7.1297, and that gives us 14.2595. Okay, so those are the uncoded versions of the mean, of the median, and the standard deviation. These would have been the summary statistics we gained if we used the original data. Okay, so the following year, the company has 25 positions available. The company manager decides not to offer a position to any applicant who takes 35 minutes or more to complete the aptitude test. The company has 60 applicants. Comment on whether or not the company manager's decision will result in the company being able to fill the 25 positions available from these 60 applicants. Give a reason for your answer. Okay, so the first thing that my mind's gone to is the median. The median value was 33, and the median represents the point at which 50% of people completed the aptitude test faster than that, and 50% of people took longer than that to complete their aptitude test. So I can assume 50% of the applicants will complete it in faster than 33.3 minutes, which means they will get the job, or they will be offered the position, because the manager's stipulation is that they will not be offered a position if they take 35 minutes or more. Okay, so the median is 33, which is less than the 35 cut-off limit, so we can expect 50%. Okay, so we can expect 50%, that's 30 of the applicants, to complete the aptitude test before 33.3 minutes, meaning there will be job offers for all the 25 positions, potentially even more. This is a 2-marker here, so just saying the median is less than the time limit wouldn't be enough. You definitely have to have a comment that's in context to get all of your marks for this question. Okay, moving on. So here we have a discrete random variable. The discrete random variable follows a binomial distribution where n is 30 and p is 0.28. Find the probability that x is in between 5 and 12, including the 5, not including the 12. Okay, so straight away we should be writing this with equals to signs. So I'm going to say the probability of 5 less than or equal to x. And what number do we want to include up here? 12 is not included, 11 is the value that will be included. All right, so this is going to equal probability that x is less than or equal to 11 minus the probability that x is less than or equal to 4. I want to keep 5 within the value represented, so I'm going to eliminate everything from 4 and below. These values here, we're just going to need to look up. We can use our calculators for that. These will not appear in the tables because this p-value is not one that you can expect to find on the tables. So typing this into your calculator is how you're going to get your results. And we're looking for 0.8939 minus 0.0495. Okay, on your calculator you would have needed to use the BCD function, and you may well have typed this in as, so typing that onto your calculators would have got you the answer all in one, but obviously it's good practice to show the values that you're using as you go along to get those method marks. Okay, moving on. Past records from a large supermarket show that 25% of people who buy eggs buy organic eggs. On one particular day, a random sample of 40 people is taken from those that had bought eggs, and 16 people are found to have bought organic eggs. Test at the 1% significance level whether or not the proportion P of people who bought organic eggs that day had increased. State your hypotheses clearly. All right, hypothesis test question should be getting our marks here. Let's pull out everything that we need. All right, probability someone buys organic eggs, 25%. Sample size is 40. The test statistic is this 16. This is how many happen on that particular day. We're given our significance level of 1%. And let's just check, is this a one-tailed test or a two-tailed test? It's going to be one-tailed. We're told that the probability had increased, or the proportion had increased. Okay, let's get into this hypothesis test. The null hypothesis says that the probability of someone buying organic eggs, or the proportion of people buying organic eggs, is 25%. The alternate hypothesis says that actually that has increased. If the null hypothesis is correct, then we're assuming a distribution is binomial, n equals 40, p equals 0.25, which has an expectation of 10. So that's 40 times 0.25 gets me that expectation, and our significance level is 1%. Okay, so a couple of things to be clear about. What does X represent? What does P represent? Okay, so be careful that you specify we're talking about the organic eggs. If you'd said that this was just people buying eggs, that would be slightly incorrect and you wouldn't get your credit here. Let's also say what P represents. And P represents the probability that someone buys an organic egg. Just down to variations in the mark scheme, sometimes this is a mark. So just get in the habit of making sure that you state these two things as you're doing your hypothesis test. Too much of a straightforward mark to be missing out on. Okay, so we can get into the test now. Our test statistic was 16. We're going to try and see whether 16 is far away enough from the expectation for us to reject H0. Quick diagram. The expected number was 10, so that's somewhere near the middle. 16 is obviously going to be off towards the right, and I just want to know, is 16 far away enough that'll be beyond this blue region, which I've set to 1%. If it is beyond that blue region, I'm going to say that I will reject the null hypothesis. If it's not, then there's not enough evidence to reject the null hypothesis. Probability that X compared to 16, the probability that X is greater than or equal to 16. 16 was already above what we expected. I'm testing to see if it's even further away, even further above what we expected. Okay, to work this out, we straight away need to do a 1 minus. Our tables and our calculators are not set up to do greater than or equal to probabilities. The corresponding number over here will be 15. So either in your calculator or on your tables. Okay, and that's the value that we get, 0.0262. Is that small enough to be significant? So the comparison, this is bigger than my significance level. If I was to sketch that on here, it's going to take up more than 1%. It would be all of this space. 16 is likely to be over here. It's not far away enough to be significant. Okay, so it's not enough evidence for us to reject H0, and I'm going to conclude that actually on that specific day, the probability of someone buying organic eggs was not larger than on any ordinary day. Okay, so my mathematical conclusion, not enough evidence to reject H0, and a contextual conclusion. All right, so not enough evidence to suggest the proportion of people buying organic eggs had increased. So be careful to get all those bits down to get all of your marks. These two conclusions sometimes are lumped together, and if you make one without the other, you may not get the credit for it. Okay, part C, state the conclusion you would have reached if a 5% significance level had been used for this test. So this comparison is what we use to make our conclusion. If we'd been comparing to 5%, then our test statistic would have actually been smaller than the 5%, and we would have made a conclusion to reject H0. We would have had enough evidence to reject H0. So we would have had the reverse of the statements that we have here, and that would have been enough to suggest that actually the proportion of people buying organic eggs had increased. So enough evidence to suggest the proportion of people buying organic eggs had actually increased. Okay, on to question 3. Pete is investigating the relationship between daily rainfall and daily mean temperature in Perth during 2015. He used a large data set to take a sample of size 12. He obtained the following results. Pete drew the following scatter diagram for the values of W and P and calculated the quartiles. An outlier is a value which is more than 1.5 times the interquartile range above Q3 or more than 1.5 times the interquartile range below Q1. Show that the 3 points circled on the scatter diagram above are outliers. Okay, so what I'm going to do, I'm actually going to draw the boundaries for outliers for both of these variables. So for the daily mean temperature, which is P, let me identify where the outliers would be. At the lower end, it's the lower quartile minus 1.5 interquartile range, and at the upper end, it's the upper quartile plus 1.5 interquartile range. 1010 minus 1.5, this one I'll just quickly do it in my head, that's 3.5 for the interquartile range. On the calculator quickly. All right, and for the upper quartile boundary, we're going to get 1018.75. Let's do exactly the same thing for W. So that gives negative 3.05. Okay, so here's our outlier boundaries for both of those variables. Let's see what that does on the graph. Okay, so for the lower boundary of the mean pressure, 1004.75 isn't even on the graph, so I can't place any boundaries there. Let's look at the top end, 1018.75. Okay, and that would appear right about there. So anything to the right of this is going to be an outlier, so that satisfies the two that are circled here and here. Let's now turn our attention to the daily rainfall. Once again, negative 3.05 isn't even represented on the graph. We're just looking for the upper boundary, which is 82.95, which would be here, and once again justifies us having an outlier up here. Okay, and that's what we have. Okay, moving on. Describe the effect of removing the 3 outliers on the correlation between daily rainfall and daily mean temperature in this sample. Okay, so just referring back to the graph we were looking at, previously it did seem like there was some negative correlation, weak negative, as there's a lot of them quite far away from what would be a line of best fit. But without those highlighted, without those circled points, the few that we're left with, they make a sort of cluster. There doesn't seem to be any correlation here at all. Okay, so next, John has also been studying the large data set and believes that the sample Pete has taken is not random. From your knowledge of the large data set, explain why Pete's sample is unlikely to be a random sample. Okay, so if we go back and we look at those original values, there are no zeros, but a place like Perth is likely to have many days of no rainfall at all. So these actually seem to be quite rainy days, whereas the climate in Perth the climate in Perth actually dictates that there should be lots of days where there is zero rainfall. So this could have been seen in the large data set for the Edexcel spec. You could have also deduced this just from the fact that Perth in Australia has a lot of days of no rainfall. Okay, so next, John finds that the equation of the regression line of W on P using all the data in the large data set is given as W equals 1023 minus 0.223p. Given interpretation of that actual figure, negative 0.223, that figure is the gradient, and the gradient always measures for 1 unit increase for P, what impact it would then have on W. So just putting that into context. Okay, so for every extra 1 HPA increase in the mean daily air pressure, the rainfall, the daily rainfall, will fall by 0.223 millimeters. And that's the interpretation of the gradient of a regression line. So John decided to use the regression line to estimate the daily rainfall for a day in December when the daily mean temperature is 1011 HPA. Using your knowledge of the large data set, comment on the reliability of John's estimate. So this question is basically asking whether there's interpolation or extrapolation, and this is actually going to be extrapolation. If you recall, in the large data set, the data does not cover the month of December. So to use our regression line as a prediction tool for December would be inappropriate. It is extrapolation. Okay, so on this last one, be careful to make sure you've included a reason. Extrapolation on its own will not be enough for the mark. In all of these questions, make sure that you have attached the context that examiner and the exam question are actually asking for to make sure that you get all of your marks. Question 4. Aliona, Dawn and Sergey are sometimes late for school. The events A, D and S are as follows. Aliona is late for school, that's A. D represents Dawn being late for school, and S obviously will represent Sergey being late for school. The Venn diagram shows the 3 events A, D and S and the probabilities associated with each region of D. The constants P, Q and R each represent probabilities associated with the 3 separate regions outside D. Write down 2 of the events that are mutually exclusive. Give a reason for your answer. Straight away, mutually exclusive means that there is no overlap. The 2 events do not happen at the same time. So the 2 mutually exclusive events are A and S. Okay, no overlap, no intersection. The 2 of them must be mutually exclusive. The probability that Sergey is late for school is 0.2, and the events A and D are independent. Find the value of R. Okay, so we'll start right here. The fact I've been told the probability that Sergey is late for school is 0.2 means I instantly know that Q plus 0.05 must equal 0.2. Meaning Q must actually equal 0.15. Let's add that in here, 0.15 for Q. Okay, on top of that, we were told that events A and D are independent. If they're independent, then the probability of one multiplied by the probability of the other must equal the intersection. So from there, I get that the probability of A multiplied by the probability of D must equal 0.1. I know the probability of D, it's 0.25. So the probability of A multiplied by 0.25 must equal 0.1. And once again, rearranging the probability of A must equal 0.1 divided by 0.25. Okay, and if the probability of A is 0.4 in total, similarly to before, we then know that P plus 0.1 equals 0.4. P must equal 0.3. And finally, all of these probabilities should add up to 1. So sum them together, subtract from 1, and that will give us R. And that gets us an answer of R equals 0.3. Okay, so let's be really careful here. We used the test of independence. As soon as we were told that they were independent, we straight away had to use this knowing that the probability of A times the probability of D must equal its intersection. That will always hold true for two independent events. Okay, so Dawn and Sergey's teacher believes that when Sergey is late for school, Dawn tends to be late for school. State whether or not D and S are independent, given the reason for your answer. So once again, let's get in with that test of independence. So they're going to be independent if the probability of D multiplied by the probability of S equals the intersection of D and S. Okay, so we know the probability of D is 0.25 and the probability of S is 0.2. Does that give us the intersection being 0.05? And yes, it does give us the intersection, which means actually these two events are independent from each other. The event of Dawn being late to school and the event of Sergey being late to school have no impact on each other. These two do not affect each other. That's the definition of independent. The teacher's belief is not correct. All right, and there we have it. The teacher's belief is not supported as D and S are independent. Okay, make sure that you do have this formula internalized. It seems that that's going to come up quite a lot. It came up twice just in this question here. Make sure you show your working out and your calculations to get your method marks and to be guaranteed that you get the credit that's worth all of your marks.